Hello, everybody. My name is Evan Quinn, and I'm a researcher from the Technological University of the Shannon, Midlands, and Midwest. And I'm a part of the Information Technology Research Group called CAR, and I'm a PhD candidate. So, the title of my research paper is Standardized Object Detection and Human Action Recognition in Combat Sports. To introduce the subject, combat sports are fast-paced and complex. Traditional performance analysis is manual, subjective, and slow. Our study introduces automated, real-time, and explainable framework using modern computer vision and machine learning techniques. Specifically, we implement You Only Look Once, YOLO, and transformers to enhance training feedback and tactical analysis. This study is based on a pragmatic philosophical framework, emphasizing the identification of practical solutions to research challenges, and it advocates for the utilization of the most effective methods to investigate the research questions. So, moving on to the system overview. Our system has three key modules: YOLO v5, which is used for fast, accurate detection of people, equipment, and actions; transformer models, which are used for understanding sequences and context in movement; and finally, generative AI, such as GPT-2, which was implemented, which is used to turn detection outputs into textual insights for coaches and athletes. The system is modular and scalable, with real-time capability and a user-friendly Streamlit interface, all coded in Python. Moving on to the architectural diagram. So on the left, you can see the GPT-2 model overview, and the YOLO v5 model is in the middle. And on the right, you can see a flow of how the models are integrated together, starting with a video input, which moves into YOLO v5, and the YOLO v5 detections are transformed into input sequences, which are embedded in the transformer model, and the transformer moves on to output the sequences generated into a GPT to generate descriptions of the data. The data set and training, we created a custom data set with over 9,400 images and 31,000 annotations across 6 different classes. The classes include person, boxing bag, low guard, high guard, punch, and kick/knee. We merged kick and knee together. The training achieved 98.1% mean average precision at 50% and 63.3% precision with 96.9% recall. The model was especially accurate on person and boxing bag. We used extensive data augmentation to improve generalization and transfer learning to accelerate training. Moving on to the model evaluation, we validated the model through standard metrics such as precision, recall, F1 score, and mean average precision. Also, the model was validated by comparison to experts on 3 15-second long video clips. And for example, in video 1, we got 4 experts to count the total actions and specific actions in the video. The expert counts range from 39, 2 experts observed 41 total strikes, and finally 43 total strikes for the final expert. Our generalized test model detected 41 strikes with 50% agreement when compared to expert evaluations. The GPT insights, we integrated a GPT-based module to generate natural language summaries from model outputs. This feature was used to show how the data could be used to produce insights for coaches, analysts, or athletes trying to improve. Some examples of the GPT insights are as follows. The athlete landed 27 punches during the entire session. Only 4 kicks were executed against the boxing bag. Most actions were spent in idle. There was a high guard was a frequently used defensive position, and punch sequences comprised the largest action category. So the impact and future work. The framework was developed without implementing pose estimation models. The aim was to prove that single-shot object detection from YOLO can be used to implement real-time human action recognition for a variety of scenarios. The framework supports the possibility for training optimization and automated feedback within the context of combat sports. Some future work includes expanding the dataset with more diverse action types, with the aim of improving rare action detections such as takedown, clinches, and more. And finally, the final aim is to improve GPT responses to give a better understanding of the model outputs. So moving on to a demonstration. And you can see here the different confidence scores attached to each object, where you can see High Guard has a little bit lower of a confidence score than Punch in this example. So the conclusions. In summary, we've built a standardized explainable system for combat sports, combining fast and accurate object detection with YOLO v5, temporal understanding with transformers, and human readable summaries with GPT-2. Future work should aim to improve the dataset, implement faster and more accurate object detection models, and improve the inputs from GPT models for more actionable insights relating to combat sports. And thank you.